Welcome. This question says a force of 6 newtons pointing along the positive y-axis is used to displace a 5 kilogram object by plus 3i minus 2j plus 4k meters. So that's a displacement vector. How much work is done by the force? So let's visualize it. Here's our particle, and I'm going to say it's 6 newtons. There's the force that's been applied to it. And whatever's going on before this causes a displacement of plus 18i minus 12j plus 24k. No, sorry, reading the answer there. I'm not sure that is the answer, but I'm reading an answer there. This is reading plus 3i minus 2j plus 4k meters. Okay, so I need to find my answer, and I know that the work done by a force is equal to that force's magnitude times that displacement's magnitude times the cosine of the angle between them. But I don't know these magnitudes. I know one magnitude, but I don't know the angle, and I don't know the displacement. Another possibility is I go to the cross product, which is my work done is equal to the vector force dotted scalar product with the vector displacement. The problem I have with that is that, well, I have one vector, but I don't have the other vector. So I'm between two stools here, and it turns out that the easiest thing to do it's easier to find the vector associated with the force than it is to find the magnitude and the angle needed to do, the top equation. So what is this equation? What is this vector? And this would be, well, there's no component in the I direction. It's plus 6 in the j direction because it's 6 meters along the positive y-axis. It goes x, y, z. So y is the j in the ijk components, and 0 in the k. And that would be in meters, newtons. So then I can say, okay, work done by that force is equal to the force, which is 0i plus 6j plus 0k, dotted with the displacement, which is 3i minus 2j plus 4k. And the process of doing a dot product is I take the first coefficient, from the first vector, and I multiply it by the first coefficient from the second vector. And then to that I add the product of the second coefficient from the first vector, and I multiply it by the second coefficient from the second vector. And then to that I add a product of the third coefficient of the first vector multiplied by the third coefficient of the second vector. Or you multiply your i's by your i's, and your j's by your j's, and your k's by your k's. So this comes out to be, well, 0 added to minus 12 added to 0. And so work is equal to minus 12 joules, which means that energy is taken away from the object. Its kinetic energy is reduced or something like that. Common mistakes. Probably the most common mistake is people say, well, I've got a number and a vector, so let's just multiply them together. And they give a vector answer, which is the wrong vector answer. It's the wrong answer. First of all, work is not a vector. And secondly, even if it was, this would not be. Well, no, it doesn't matter. It's not a vector. Then the second thing is they multiply it out like that, and then they say, oh yeah, it's not a vector, so let's just add all these numbers together. So they get 18 minus 12 plus 24 equals 30. That's not the right number. And then the third thing is they work out their value, and then they ignore the sign. So we end up with a variety of errors on this. Dot products come up all the time. And the skill of being able to read words and determine what the vector should be, rather than having rather than having 6 newtons pointing along the y-axis, being able to write that down as 0i plus 6j plus 0k. That skill, added with knowing how to do a dot product, is a very valuable skill. So I commend you to get used to working out what a vector would be from its word description. So there we have it.